G'day, it's Bill here from Sidereal Trading. As you can see, I'm not in the office today. It's night time and I'm in my spare bedroom at home. Now we've got a task to do. There's a star out there in Coronae Borealis that's about to go nova, which means that it's going to get really bright for a week or so. It hasn't happened yet and I want a before shot. It's not a very difficult shot to get. I'm just going to take 20 short images and stack them up. But I'm at home in Melbourne. I'm going to take the shots using a remote facility in central Victoria, which is a couple of hours drive away from here. So this is the way it works. First, and I've already done this, I've checked the weather report and the satellite image for the area. The weather looks good. Second, I've connected to the imaging computer at the site. The way this works can be different, so I'm not going to concentrate on that. Third, I've checked the SkyWatcher for the dome. There's one on the pole right next to the dome. And finally, I've looked at the external camera on the facility. I'm assured that the weather is good and I can open the shutter without getting the scope rained on. So what I'm going to do is this. I'm going to connect to the Voyager Web Dashboard on the imaging computer. Once I'm there, I'm going to run an automated script that sets the facility up for imaging. Once that's ready for me, I'll point the telescope to our star, which is called T Coronae Borealis. It's also known as HIP 78322, I think. Then I'll get my 20 10-second shots manually. I'm just going to click the button 20 times. Now I could run a sequence for this, but it's not a very deep image that I need, so this is just easier. After that, I'll run a second script that shuts the facility down nicely. So I'm going to get my desktop screen onto this video, and occasionally I'll bring in the internal or external surveillance cameras when something interesting happens. So let's start. Okay, here's the web dashboard. Click on Connect, and it's connected. Now we scroll down the bottom to the drag script management pane and click on Get List. This brings up all the available scripts. We'll look around for Startup. There it is. Click on Select. Now click Start. We'll scroll up to the activity log so we can see what's going on. It's going to turn on some components with a short time gap between each step. These timeouts are a bit dull, so I'll fast forward a few. Turning on the mount and the accessories. That's the camera, the focuser, etc. And the cover, if you've got one. We call it the flippy flap. Next, choose a profile and hook up to it. This could take a minute. Okay, done. Now we'll prepare the dome and the mount. Here's the internal camera. We'll start cooling the camera and also move the scope to near the equator and meridian. You can see the scope slowing now. We're going here because it's a good place to calibrate the auto guider if we want to, and it also gets the scope pointing to the shutter, so when we do slave the dome, it doesn't have a long way to go. The dome's a bit slow. Oh, by the way, slaving the dome means have it rotating automatically, so it's always in front of the telescope. Okay, we're there. Now we'll slave the dome and open the shutter. Here's the external view of the dome. You'll notice that these cameras are very sensitive to infrared light, and so they can kind of blind each other. For long exposures, we normally turn the internal one off and maybe the external one as well. Okay, don't need that view. Now we're syncing the scope to the sky. This takes a photo of the stars, plate solves them, and uses that as the current position. It's like a one-star alignment. Okay, it's synced. Next thing is an autofocus. The way this works is it takes 7 images, moving focuses between them, and it calculates the best focus position from that. 1, 2. There's the calculation, and it'll go there and take a confirmation shot. Well, that beeps means we're done. Scroll down. Action end OK. Yes, we're done. So now it's passed control back to us. Okay, so now we go up to the here, the mountain target pane, where we can type into the object name field HIP 78322 and click Local Find. That goes and finds the coordinates. You see them change? That name has changed as well. Most stars have multiple catalogue names. So now we click on Send Coordinates to FOV, that's Field of View. And then we can scroll down to the Virtual Field of View pane. There's Epsilon there, the bright one. Okay, so let's actually move the telescope there. Click on Precise Go To and watch the camera. Okay, we're slowing. You'll notice that not only is the telescope moving on the mount, the whole mount looks like it's rotating. That's because the dome is moving and the camera is on the dome top. It doesn't move very much because the target itself isn't far past the meridian, so we were pretty close already. Okay, it's taking a shot to see where it is. We'll scroll down a bit to see what it's doing. That's the last image it took, not where it's currently pointing. Okay, it's downloading a shot. There's Epsilon to the side and it's plate solving. I'm going to set up our shots while it's thinking. 10 seconds and my normal gain 56, offset 76. Oh, it's getting another shot to confirm the target. You might see a small change in the image. Downloading. Okay, it's made a small adjustment. Plate solving. Okay, it's happy it's on the target. Okay, so now over to me. We're on the target, in focus, and the mount is tracking. The camera is chilled and we've dialed up a 10-second exposure. All we need are about 20 images that we can stack. So for this exercise, all I have to do is click camera shot 20 times. Each one takes 10 seconds to expose and a couple more to download. You'll see the progress of each shot in the pane to the right of the camera pane, but it's pretty repetitive. I think I'm going to edit out a chunk of this. Click on camera shot and wait. Progress moves up. And we're downloading. There's the new image. And again. Okay, last one. And we're done. Now to shut down, there's a script. So you scroll down to the bottom where the drag scripts are, get the list and, oh, it's right there, shut down. Click on select, bring up the camera, click start. The first thing it does is close the shutter. You'll see that coming down in a minute. There it is. It's very important that we use the video to confirm the shutter is closed. Next, we start warming the camera because it takes a little while. We also unslave the dome and home the dome. You can see the dome moving. Okay, that's done. We'll park the scope. There it goes. Now we quit some software, disconnect Voyager, and wait for the camera to warm. This takes a while, about 7 minutes, so I'll cut the video here. Nearly there. Okay, we're done. The dome is back in its resting state. So now you need your images. That's why we did all of this. Depending on your setup, your images might have been copied to somewhere you can get them. So now it's time to process it. And just as a matter of interest, here's a single image of the 20 I got. And here's the stack. And this is the star. It's pretty dull because the nova hasn't happened yet. By the time you see the video, it probably will have. So now it's time to log off. Scroll up to the top where the connection pane is. Click disconnect. Then confirm. Oops. Now you can close the browser or go to the CloudWatcher or whatever. You're done. So that's it. We've got an image from a dome miles from where I live. It could have been on the other side of the world. If you're interested in how all this works, or if you're interested in doing this sort of thing for yourself, or your school or your club, let us know. We've set up quite a few now, for schools mostly, and we're getting fairly experienced. So as usual, if you like this video, like and subscribe. We're on the YouTube channel at Sidereal Trading. You can contact us directly as well. So I'm Bill from Sidereal Trading, and I'll see you next time.